Modern manufacturing faces a new kind of complexity. Production lines must adapt to fluctuating orders, tool changes, and unplanned downtime, all while keeping delivery promises. Traditional scheduling tools struggle to keep pace. They're rigid, slow to update, and disconnected from what truly happens on the shop floor. When plans fall apart, operators improvise and performance suffers. Testing new schedules directly on live equipment risks costly disruption. To compete, factories need a smarter, safer, and faster way to plan, one that unites optimization with real-world validation. We begin with planning inputs coming from ERP and MPS systems, production orders, deadlines, calendars, and capacity expectations flow directly into the scheduler. Alongside these, the system incorporates production rules and master data routings, setup times, operator skills, and business constraints, so it understands exactly how the factory operates. At the center of this workflow is the scheduler dashboard. Here, planners can view jobs, constraints, layouts, and scenarios, and initiate optimization runs with a single click. The system reads production data such as G-code and CAD files to analyze machining operations, tool paths, program lengths, and machine capabilities. It also incorporates a detailed model of the physical factory, CNC locations, robots, AGVs, travel graphs, work envelopes, and spatial constraints. In addition to importing existing layouts, the built-in layout editor allows users to generate fully accurate factory environments by defining sizes, scales, and positions directly in the editor. This makes it possible to create a high-fidelity 3D factory model even when CAD data is unavailable. Regardless of the method, the manufacturing scheduler consistently operates on a high-fidelity representation of the shop floor. Behind the scenes, the G-code analyzer extracts actual process requirements, while real-time data keeps the system synchronized with current machine status, data whip progress, and active operations. Using all this information together, the solver generates an optimized schedule, assigning work to the right machines, balancing workloads, and organizing the production flow as efficiently as possible. Before the plan is released, it undergoes a validation step through NVIDIA Isaac Sim. Inside a digital twin of the factory, the schedule is simulated to verify feasibility, test interactions, and ensure that all movements and timings are physically achievable. The result is an optimized and validated production plan, ready to be executed on the real shop floor. The process begins by defining your digital factory layout. Machines, printers, and AGVs are imported from a single JSON configuration, forming the foundation for resource detection and constraint mapping. Next, the scheduler analyzes capabilities, dependencies, and calendars to generate the most efficient sequence of jobs. Each schedule aims to minimize idle time, balance workloads, and reduce travel distances, all while meeting due date objectives. Once generated, the plan is visualized as a live Gantt chart with detailed metrics: make span, utilization, throughput, and work in progress. Every job, route, and resource is traceable, transparent, and ready for validation. Inside the digital twin, the plan comes alive. Autonomous AGVs transport materials, robotic arms perform handling operations, and CNC machines execute their assigned tool paths, all governed by real physics. On-screen labels update in real time: machine status, job ID, estimated completion, and queue length. Decision-makers can observe the entire workflow from any angle, seeing exactly how the schedule performs under realistic operating conditions. No guesswork, no abstraction, just a photorealistic validation of every decision. The outcome is measurable improvement across every key metric. Idle time drops, machine utilization rises, and throughput increases without additional hardware. By validating schedules virtually, factories reduce downtime, energy consumption, and risk. Rapid replanning keeps operations resilient to disruptions, from rush orders to machine maintenance. Managers gain a single source of truth, with visual insights they can trust before implementation. The manufacturing scheduler is more than a proof of concept. It's a foundation for data-driven, closed-loop manufacturing, ready to scale across multi-factory ecosystems. Supported extensions include real-time data feeds, advanced physics simulations, and integration with NVIDIA QOpt for autonomous optimization. At Grid Dynamics, we engineer digital transformation that connects vision with execution. To discover how Manufacturing Scheduler can accelerate your production intelligence, schedule a discovery session with our experts today.